Everybody filters in. Don't worry, there's just you can take your seats. Just a few slides where we introduce myself in the talk. My name's Ian Cooper. You can find me on Twitter as iCooper. My DMs are open. I'm usually happy to engage a little bit about anything I'm talking about. Today's talk is going to be about if we have asynchronous APIs, so you can think of those as events or messages. How do we go about owning and managing them? I do quite a few talks about how we build event-driven architectures and how we design them. And this one's more about, well, you've got one, how do you look after it? How do you do all those things that kind of like fall into the line of admin for your API? So it says that I'm old. I only ever really draw attention to the bottom point. I got my start in speaking because I still do. I ran a user group, and when we started, there was nobody else to talk apart from us. And that's just led me up here. Doesn't mean I'm particularly any kind of genius. Any of us really can do this, and I do encourage you to have a stab at it. It's great, and all of you will know something that someone else doesn't know, and very easy, I find, to think, but I don't know anything. And it's like, actually, but if you do know some things, you just don't realize you know them, and there'll be a junior dev somewhere that wants to know what you know, right? And I work on an open source project called Brighter. It's a messaging framework for .NET developers. We have a Python version called Brightside. All right, we're going to talk about the notion of endpoints. What are they? Why are they important to us? And we'll get a little bit into bits of domain-driven design, a little bit of the ideas of contracts. Then we'll talk about the notion of having decided what endpoints are in the world of asynchronous kind of conversations. We'll talk a little bit about discovery of those endpoints, and then we'll get into describing them, the endpoints, and particularly the contracts they hold. And then we'll get a little bit into some of the interesting things we can do once we have those, like using it for infrastructure as code, and explore some of the ideas we've been playing with. One of the things that I like to make sure we're all agreed on, first of all, though, is what do we mean by an asynchronous API, right? So what's a synchronous conversation? In a synchronous conversation, both parties must be present for communication to succeed. Right? You both have to be there at the same time. And the canonical example is, of course, a phone call. Right? I phone you up. If you're not there, there is no communication. Right? Now, nowadays, the only person that phones me is my mum. My mum is in her 80s, so I think that's fair, and she likes to hear my voice occasionally. Everybody else just uses WhatsApp or Messenger or Signal or whatever mechanism we have agreed to send messages over. And the reason people do that is because it's easier. Typical protocols here for synchronous: OpenAPI, GraphQL, gRPC, Thrift, and SOAP. So asynchronous conversation is the other kind, the kind we're really all used to using. In asynchronous conversation, the receiver does not need to be present at the same time as the sender communicates with them, using store and forward to pick up the message later. Canonical example would be snail mail in a letterbox, right? I send you a letter. If you're American, it goes and lives in one of these nice mailboxes with a flag. If you're British, it just pops through our door. But what it means is you can get to the mail whenever, right? Whenever you're ready, when you come home at the end of the day, there's the mail waiting for you. You didn't need to be present when I sent it. So I decouple sender and receiver in terms of in time. They don't need to both be available at the same time, which generally increases the availability of our platform. It is much easier to build a platform where I don't have to have you both available at the same time, right? Some probability theory that you probably did in maths years ago explains to you it's much easier to get uptime where you don't have to both be simultaneously available. And the real question is, how do we describe these kind of things? So WhatsApp, etc., all those kind of things you use today, they're all asynchronous conversations. And protocols today like RabbitMQ, Kafka, SNS, they're all asynchronous, right? Okay, let's talk about endpoints. So back in the day, there was a toolkit called, I think there's an open source version now called Windows Communication Foundation. Built by some smart people, outdated nowadays. It's really based around principles like SOAP, but it had a quite nice definition of what an endpoint was. And really based on that, endpoints are places where messages are sent or received, and they define the information required for the message exchange. So just a conceptual idea, right? But we have an app, and our app wants to basically send messages or receive messages, And what we do that through is an endpoint. And it isn't necessarily just for messaging, right? Even for something synchronous. So, we can think about an HTTP endpoint, somewhere where we send and receive HTTP. Or we can think about, a messaging endpoint for Kafka. It's somewhere where we send and receive Kafka, right? In order for an endpoint to be useful to us, we have to think about where messages should be sent, how they should be sent, and what they should look like. And what WCF used to call these the ABCs, address, binding, and contract, which is kind of easy to remember, so I quite like that little model of how these things work. All right. So what are these things in terms of what the messages should look like, right? We'll worry about basically where and how they should be sent in a second, but what are these things in terms of what they should look like? What are we sending? Okay, let's do a little bit of DDD theory. So I have a business usually that I am working for in terms of delivering software. And the business does some stuff. And we talk about that being the domain, right? So I currently work for Just Eat Takeaway. Our domain is the domain of what they tend to call quick commerce, getting you your food before it gets cold, right? And now people are extending into getting your groceries before effectively you, get thirsty. And within that domain, we may define a number of subdomains. So the domain's big and hard to think about, and we don't want to build huge monoliths anymore, right, that deal with the whole thing. So it's split up in smaller parts, like how do we onboard a restaurant? How do we determine if a restaurant is currently available to offer food? And typically what we would then do is say, okay, we need to basically create a model of that subdomain. So a bounded context in DDT is just a model of our domains, our subdomains in this case. We could model any given subdomain in a quite large number of ways. A bounded context is just one model, right? We've chosen to basically represent it in C# or Java, or all of those things would be equally valid models. The bounded context just says, here is our model, right? Here is how we chose to represent that. If we are lucky, there is a kind of one-to-one alignment between subdomains, like, hey, we've got a subdomain about restaurant onboarding, we've got one about restaurant availability, and we have a context for each of them. In more legacy systems, you tend to find that alignment slips, right? What happens is we begin to think about our domain in new ways, our business may pivot or change, we may not want to really consider onboarding restaurant to really be a domain we deal with so much anymore, and we may find effectively we now have a new subdomain to think about, and our old bounded context forms part of that. That's why we do this exercise called context mapping from DDD. Right? But for the minute, let's just assume we have a nice perfect world in which subdomains and bounded contexts are pretty much the same thing, but just to be aware they're not, right? And a bounded context is the code, the schemas, even the team boundaries, basically, that represent a given domain, right? So you can think of it almost like a business capability. It's the people, the processes, and the technology that go to basically make up a representation of a given subdomain. That's what a bounded context means. And within that bounded context, we agree the meaning of certain terms. You'll notice here that we have both a restaurant and restaurant onboarding, and we have a restaurant and what's going to be called restaurant availability on the other side. And we may not agree in those two models what a restaurant looks like. Restaurant onboarding may care about things like the address, it may care about the phone number, it may care about the name of the manager, effectively who's on shift at a given time. But the restaurant availability may just care about the hours that the restaurant keeps, how long it takes basically to close down the restaurant at the end of the evening so that they won't do a service there, etc. Right. So we're modeling quite different things, although they're both a restaurant. We call that a polyscene. As a name for a bounded context, right? And so we've got this idea of different representations of a domain concept. Okay. Now, well, we're here to talk about APIs rather than DDD, so how is that relevant? So in this model, it's quite likely that what happens is I onboard a restaurant, and having onboarded a restaurant, the information about a new restaurant flows to our restaurant availability service, where effectively someone can go in and start entering things like shift hours. So our restaurant availability service needs to know about restaurants which have been created by restaurant management. And typically, if we're going to be asynchronous in order to increase the availability of our platform, then it means restaurant management is raising some kind of event saying, here's a new restaurant, or here's an updated restaurant, or someone took that restaurant out of our platform. And the restaurant-based availability service has to listen to those messages. Okay. So what is the content of that message? Where does it come from? Well, we have a relationship here between restaurant management, which effectively seems to own this conversation. It's the person initiating the conversation, and restaurant availability, who is essentially receiving information. And we tend to think about them as being upstream and downstream. The downstream, the receiver, depends upon the upstream team. If the upstream team makes changes to its model, the downstream team would need to react. The reason we talk about downstream and upstream is the analogy would be, think of two cities, one sharing a river, and one is upstream and one is downstream. If the upstream city starts dumping all of its waste completely untreated into the river, it may well be that the downstream city is drinking that as its drinking water. That's a problem for the downstream city. So what we say is we should try and manage this relationship so that the restaurant management team, the upstream team, are not just basically destroying the lives of the downstream team. And so we say that they have a customer and supplier relationship, that the upstream team is the supplier, the downstream team is the customer, and the upstream team should think about looking after the needs of their customers. Otherwise, we end up in this kind of world, right? Conformance. This is kind of like we have a supplier, an upstream and a downstream, but they don't really care. And in this model, what happens is the restaurant team who are doing on the onboarding, they say, we're going to take our internal data structure that represents a restaurant, and we're just going to serialize that out as the message. Or if they've decided for some benighted reason to do event sourcing, all of our event sourcing events, we'll just basically expose them and send them down the system. Hey, we've got internal domain events saying a restaurant's been onboarded. That's what we'll send over Kafka to everybody else, telling them there's a new restaurant. All right. And the problem with that is, as soon as that team says, I've got an interesting refactoring here, maybe we need to change the restaurant identifier from being this integer, because we've got superscale now, and that identity number on the SQL server is no longer working for us. We're going to shift over to Dynamo and use a GUID instead. They completely break the downstream team, who've been sitting there going, we've got lovely integers for our restaurants, and that's what we've been collating all this time. Right? Every time you make a change, the downstream team's system breaks because their schema is the schema you have internally. So the first rule is just don't do this, right? Don't expose your internal domain model on your events leaving your API, because when you want to change it, you'll break everyone upstream of you. Or downstream of you, rather. Okay. Or you can't change anything because you'll break people downstream of you, right? Like I say, you can't change that, you'll break us all. So what are our options? Well, one option is if the upstream team are not being particularly helpful, for whatever reason, they're not particularly good team players, is that the downstream team is being built what they call an anti-corruption layer. So an anti-corruption layer provides an ad hoc translation service per customer that translates the format used by the supplier to that understood by the customer. In other words, I build something that says, when I get their message, I'll turn it into something I can use internally consistently. So it'll always look like this, and I don't have to keep changing my code. The only thing I have to do when the upstream team changes their internal representation is figure out it broke, go to my anti-corruption layer, fix it, and then effectively it'll flow through my system correctly. That's kind of our least worst option. The only slight problem with this is, if there's a whole load of people listening to restaurant onboarding, so certainly in my current field, lots of people want this restaurant data, right? They want to basically know about restaurants. They're all writing anti-corruption layers. And the second thing is, if the upstream team don't tell you before they decide to change their internal model and you break everybody, you still got to fix everything, even though they've got one place to fix it for each individual team, right? If you're lucky, they tell you and you can go and fix your anti-corruption layer. That doesn't always work because they don't necessarily know you exist. So that's kind of your least worst option. The other option is what domain-driven design calls an open host service, which is just a fancy name for saying, get restaurant management to expose a proper API. Okay. So an open host service reduces the duplication in many anti-corruption layers by supporting shared models. The upstream team agrees to support an external model that may differ from their internal one, and implies an open host model that supplier agrees to support and customer agrees to depend upon. What does that mean? So what happens, it means is restaurant management say, okay, we are going to define what we send and you can rely on that. It'll be like an API, we'll publish it somewhere, and we'll say, this is what a restaurant looks like. It may not be how we represent it internally. In fact, we may keep changing how we represent it internally, but when we send something externally, this is the shape it will have. And if we want to change that shape, there's now a process of negotiation between us and all of the consumers. Okay. It may be that we ask you to be tolerant readers, right? So tolerant reader just means, effectively, you'll accept things that aren't necessarily exactly the shape you predicted, but they don't harm you in any way. So if somebody adds new fields that you don't understand, you don't care. You just ignore those because they're not for somebody else and they're not for you, but you have the data that you want, right? You might agree early on with this team that certain fields you can have sensible defaults for. If they're missing, you'll have sensible default, right? It's missing the lat long, don't worry, you'll send them all to null island, right? To 0, null island. So you might ask the downstream team to be a tolerant reader, and that means essentially it makes it slightly easier to do some things. Add some new fields that new customers need, effectively drop some fields that most people aren't actually using in a kind of a phased process. I stop producing data there, you start defaulting it until you can actually drop it and get rid of it, right? We've moved from doing lat long to 3 words or something like that. But the key idea is you agree a contract. You agree some kind of stable contract that you'll give other people. And we talk about this as being necessary coupling, right? Here's the thing, right? I could build some software that was completely decoupled if it sat like on my computer in a basement attached to nothing, and it would be utterly useless to anybody, right? So what we have to do is accept that you are going to have some kind of dependency on things upstream on you. There's a certain amount of coupling that happens. And necessary coupling says, actually, in order to do our job, we have to listen to this information. So it's necessary coupling because to collaborate with others, we must allow others to take a dependency on us, right? So we say, okay, we are going to accept that this contract is a bit rigid, that it can't change too often, that we, the upstream team, although we can make internal changes, are limited as to the shape, the new shapes we can give restaurant by the fact that we have customers of it. And we, the downstream team, have to recognize that, we have to take a dependency on somebody upstream, but we have to take work. So this contract becomes quite important, right? And so that's why in a lot of cases, when we talk about APIs, what we want to surface to people is you should think about how you design this, because it's going to be long-lived. Once it's out there and you have a number of consumers of it, it's harder to change than some internal code. You can't refactor your API quite as easily, right? Imagine you want to do the whole thing where you've exposed an ID, which effectively is an integer, because you just picked up the identity field that was being generated for you in SQL Server. You couldn't scale SQL Server anymore, so you moved to Dynamo, and you decided you needed a GUID instead to represent it, and you wanted to put it on a string. Right? How would you do that? Well, what you have to initially do is give new ID alongside old ID, because you have people dependent on the old ID format of using an integer. And you just put the integer as a string in new ID. Right? And then you say to everybody, please get off your old ID. When everyone says to you, we're off old ID, you can, we're now reading the new ID. You can now say, great, now we're going to start shipping new ID effectively as a GUID. When everyone accepts that, you say, okay, now we're going to retire old ID, so there's only going to be new ID. And everyone goes, great. And then you say, now we're going to create ID again, but it's just going to be a string. It's going to be the same as new ID. And everyone goes, great. And then you can say, now we can get rid of new IDs, right? It's quite a lot of work. So you have to think about these things as being quite long-lived. They need a little bit of forethought and planning, and they probably need a little bit of review. Typically, the best way to review them is to talk to the people who are going to consume it, right, and any subject matter experts you have, and say, hey, let's all have a look at my API and figure out if we think what's wrong with it before we actually put it out there, right? Just think about contracts being long-lived. Okay. Habitable for supplier and consumer, yeah. So this idea of habitability, something we can all live with. All right. So you figured out that what you actually need to do is not expose your internals to somebody else, have an API, except it's a long-term contract that you can't change easily, and you need to manage basically that contract. Okay. How does anybody else find out about it? So let's imagine effectively I am restaurant availability and I decide what I need is an upstream message from somebody basically who onboards restaurants. One question would be, well, where do I find this contract? Typically, in a lot of organizations, I hop onto Slack and I post a message in some general forum saying, anyone know who produces messages for new restaurants? Who has this? This is their favorite technique? A few of you? Who has the other technique, which basically is I go to GitHub and I search GitHub for what I think the message might be called and see which team might produce it. Anyone got that? A few more GitHub searchers than Slack people. Yeah, I mean, this is very typical, right? I've got a contract, it exists, I've defined one, but nobody can find it. Okay. The other problem is the inverse. If I have a message and I need to change it, I need to change that contract, and then my first steps are in negotiation with everybody that consumes it. How do I find them, right? If I'm the producer, how do I know who consumes my message? Again, typically, someone posts a message saying, anyone using this message, can they get in touch with us if you want to change it? Or I troll GitHub saying, I wonder if anyone's actually got my message schema as part of their code base, all right? It's not very effective. So we need to document our asynchronous APIs somewhere, right? We need some mechanism to document them. We need to document our endpoints effectively. It's our contract. What do we need to document? Well, we're going to need to document the channel. What's the channel? So a channel is, when messaging terms, really just an abstract idea. It's the virtual pipe that connects sender and receiver. And we already use it for a whole range of concepts. But it's really saying there is something over which we can send messages that is somehow addressable. So in Kafka, it's your topic, right? In RabbitMQ, it's your routing key. It's SNS, it's a topic as well, right? And that it says, hey, I want to send messages to or from this thing. So we need to understand, you need to document what the channel is so you know where to find it, right? We need the protocol. Right. If it's going to be Kafka, is it going to be SNS? Right. SNS is really just HTTP with semantics. Right. Is it going to be AMQP? How are we sending this stuff? What do you need to do to listen to the things that I'm sending? And then we need to say, well, I am the sender. Right. I am this app. Probably it might be useful to know who the people are that own the app. Right. Which team? Are there any contact details? Do they have a repo somewhere? And who subscribes to it, right? But, you know, a documentation somewhere saying, hey, my app subscribes to that message. Because that tells us what's going on. So endpoints, if you remember, this is the definition we had earlier, place where message sent or received, that they tell us where messages should be sent, how they should be sent, and what they look like, right? So we've been discussing what should they look like. We're saying basically there should be a contract, which is long-lived. And we're saying also, we're discussing how they should be sent, protocols like Kafka or AMQP, and where they should be sent, so channels, right? Okay, so document a contract for an endpoint, and endpoints where message should be sent, how they should be, blah, blah. Okay. So the message is the data that we send or receive. It is our contract, effectively. And it tends to have two things, the metadata, the headers that we send. So generally, when we send something, we need metadata, which really tells us how to process the message that's in flight. It doesn't tell you what the data is that the domain cares about, but it says things to you like, what is the ID of this? Is there another message it correlates with? Is it, if it's a large message, has it been broken up into a number of pieces? Is this basically, do I expect to reply? If so, do I tell you where to reply to me, etc.? So metadata about processing the message. And then effectively the body, which tells us essentially what is the actual content of the message. We need to document both usually. The channel, right? Where the message is going to flow, the address. And the binding. And the binding says there may well be information we need to know as part of this protocol which tells us how to send messages to and from this endpoint. Okay, it may tell us how to basically authenticate ourselves in order to communicate with basically this endpoint. Right? It may tell us where the broker is that we need to connect to in terms of its basically address in order to actually communicate over this channel. So there's technical information that we have to have alongside that. And it may also have things like, you know, are we binary, are we plain text, all that kind of information. And in principle, we can have multiple bindings to the same channel. So in principle, we might actually say, hey, we talk about basically a new restaurant being created, and we make that available for AMQP and Kafka. And this talk's not really about why we might want to do that, but be aware that's possible. All right. So let's say we want to describe endpoints. How might we do that? Okay. So AsyncAPI is an emerging standard for documenting our endpoints. Who here has used OpenAPI? Yeah, quite a few of you. So really, AsyncAPI is just OpenAPI, but for asynchronous APIs instead. Okay. And OpenAPI was a direct inspiration used by the AsyncAPI developers initially, although it's moving on from that. So it's looking at the bottom, open governance. So AsyncAPI has become part of the Linux Foundation. So essentially, it is owned and controlled by a foundation effectively now. So you have some kind of like continuance. It has a community. They're actually a very welcoming community. You can get invited to their regular kind of stand-up meetings about effectively what's happening in their world or looking at new version specification. They're currently working on 3. There's a Slack channel. They are very, very welcoming. It is early enough in the lifespan of AsyncAPI. That's a small enough community of people becoming involved that you can get to know people in the community quite easily. And what they produce is a specification, which says, here's how effectively you should document your APIs. And they also effectively produce tooling, which essentially lets you work with APIs documented in that style to produce new effects. And we'll talk about that a little bit more later on towards the end. Part that in your head that you can basically build tooling off it, but we'll come back to that later. All right. Okay. So generally what you do with AsyncAPI is you document an app. What do we mean by an app? Well, we just mean, you know, some process that effectively you intend to run that has some kind of functionality. And generally your app has a role, and it may have more than one role, and it can act as a producer, as a consumer, or both. So if it's a producer, it's sending messages. If it's a consumer, it's consuming messages. Often apps do both, right? I receive messages, I do some work, and I generate new ones. So I'm both a producer and a consumer. And we document what that individual app produces and consumes. Okay. We send messages over channels, and they are hosted on a server. And maybe more than one channel, so the channel must be addressable. In other words, we have to give the channel a unique identifier of some sort, so I know effectively that you are talking about this channel or another channel specification, right? If I'm receiving 1 and sending 2, that might be 3 channels, right? So generally, channels live on a server. It's a little bit of a historic thing, channels living on a server, because generally with pub/sub, we don't really care so much about the server. We'd have a notion really more of effectively of a broker that we might care about. And the server abstraction tends to think more in terms of, hey, I am a thing hosting an API, whereas really in pub subland in messaging, we think more of, hey, here is a channel I can subscribe to. So 3 will fix that slightly. But for now, server, what we tend to use it for in most pub sub models is where is the broker that I'm using. Okay, as a message, effectively definition, you have to have a payload or a header. AsyncAPI is reasonably open to how you choose to define the contract that you're going to basically produce in your API. So by default, you can just use JSON schema to say, this is what my message looks like. But it also supports you choosing to use things like Avro. Those of you who don't know what Avro is, it's a standard that came out of the Kafka community for defining basically a schema. It has both a binary and a plain text format. But you can also use effectively protobuf. So you can use any of the kind of major players in terms of basically schema definition for things you're sending. And a channel also basically has a protocol by which messages are exchanged, so Kafka or SNS, etc. And what happens is you define a binding at multiple levels inside async. You'll see this more clearly in a second, AsyncAPI, to define how essentially that protocol is applied to either channel definitions, to how messages work, or effectively to how the server is constructed. We'll see that in a sec. All right. So what does a document structure at AsyncAPI look like? So you have basically an AsyncAPI object. It's the root object. It's a kind of document object model. All things live off that. All right. Below that, we have an info object, which is meta specification. This is where you effectively say, my team built this. This is how you get in touch with us. We are the owners, effectively, of this particular specification. All right. And so if you're a producer of a message, someone would then know you're the team, effectively, that I need to talk to about basically the stuff that's being produced. If you're a consumer, vice versa, right? It has a service object, which is basically a connection just for the server. So essentially, depending on the role, this may affect you. This may be your app could actually be acting as a server in some of the models. And other models, ones we tend to use for messaging, it tends to be basically just the address of the brokers. That's where your Kafka broker is. That's where your RabbitMQ broker is, etc. You can have multiple servers, so you can effectively say, here is my production instance, here is my QA instance, here is my local dev instance, and you can list them kind of all so that effectively people can figure out which one they should be talking to. A channels object, which basically says, okay, what are we sending and what are we sending over it? So overall, the channels object has a name and says essentially the name of this channel, which is effectively disambiguates from other channels and maps well to, say, a topic on Kafka, for example. Beneath that is a channel item and operation object, which is a bit complicated. Operation objects essentially say, am I sending or am I receiving on this channel? And what am I sending or receiving? What is the message? There's also effectively an operation ID, which kind of names the operation, which is mainly useful for things like code generation. Right? Now, there's also a components object, and the components object lets you kind of say, actually, rather than defining that thing in line, I'd like to put it in my components section. And typically what that's used for is a message definition, right? Let's put my message definition in here rather than inlining it inside the actual definition of the channel. Okay. And tags, so I can tag a given specification in case that helps me organize it and make it more searchable, etc. So, AsyncAPI object has an ID. You just need to identify basically the top level. That's all it really requires. So here I'm using an example from my open source project saying, here's a typical SOM project we use. I'm just going to give it an ID. Here's an info object. So again, I'm just using one from my open source project. You can see there's the name of the project, the URL, where you go to find us, how you email us for support, license, which is probably a bit weird internally, right? You just probably ignore that internally. But a description of the app, which is very useful, a title, a version number of your version of specification, right? So all very useful. And some tags so we can help find it. Service object, all I'm doing here is defining a local one, but you could obviously define production, etc. I'm just telling you where to find the broker that I'm going to use. And in my case here, I'm going to use Kafka, and I'm saying effectively, you can find the instance that I'm running, my local one at localhost 9092, right? And obviously for a production system, you'd have the actual production URL of your Kafka cluster. This then is a channel. So you can see it's called, for example, greeting here in the top corner. Ignore subscribe for the second, we'll come back to that. And then effectively, just imagine we're saying here's an operation performing on that channel. Here's a summary of the operation. Here's a description of it, which is longer. And here's a message. The message, just has a hash ref. We'll come back to that, saying, but all it means is go and look in this part, in the components section of that definition, rather than in line, to find what the message looks like. So it just makes it cleaner. All right. So we're saying, in the summary, we send a greeting here, and the description says, hey, this is how we send greeting to another service, and we call the operation send greeting. So obviously what we're defining is we send something on a channel. Notice we use the word subscribe. That's a bit weird, right? Why is it subscribe? Okay, so this is a bit of an anomaly that still exists in AsyncAPI 2, which will get fixed. And that is because originally when it was built by people dealing with things like WebSockets. The server was kind of a role your app might be in. And if you were in the role of a server, you were exposing operations to people. And one of those operations was, you can subscribe to me because I send messages, right? And when they flip that over for a consumer, they're like, well, I guess the consumer, you can publish to them. And actually, in some ways, that kind of works, right? If I think about how SNS and SQS work, right? I do, as SQS, give you permission to publish to my queue from SNS, right? But it's a bit weird for most of us. So I'll show you later, and with 3, it gets fixed, and they're just going to use the term send and receive to mean what we would understand to mean. But when you come across this first of all, you will do a little bit of double take and go, that doesn't make any sense. It's just history about where the spec came from in early versions. Ref just lets you basically say, hey, this lives elsewhere. You can say it lives in the same file by using a page fragment indicator to say effectively go look in the components section. That's where my definition of greetings lives. More usefully, you can say it lives in another file. Why is this useful? Because typically with a message contract, you'll both want to have it for the producer saying, I send this, and for the consumer saying, this is what I read. Now, you can go to the effort of saying actually producer and consumer are not necessarily the same, because the consumer may choose to consume only a fraction of that message. They may only want 4 of the 5 fields. They could choose to define that, which lets you get a very simple version of what we call consumer-driven contracts, which lets you say, well, if I drop that field, do any of my consumers actually use it? I haven't seen many folks actually do that. Most folks are just like, it'd be nice to get everyone to document their endpoints, and if the producer's going to tell us what their message is, the consumer will just say, that's what I use, right? So sometimes with this stuff, you're better off getting to phase 1 with most teams than you are effectively worrying about, wouldn't it be nice to have a proper CDC over it? So this is what a component looks like with a message inside it. We've done by ref. You can see essentially the message has got a name. We have a whole load of effectively fields. More interestingly, perhaps, we have these traits and payload. So all we're saying is that this is the message. The message has a payload, and we're effectively breaking up to make it easier to read. In the same component space, we've defined an area called schemas, and we're going to put our actual message, our payload schema into there. Traits basically say, hey, there's something I want you to effectively merge in, right? And typically, quite often, a major use case for this is things like headers. So you can define somewhere in a file a set of common headers that you use in your enterprise when you're sending messages. So maybe you effectively want to define that you use, we'll talk about it later, the CloudEvents specification. You could write up traits for CloudEvents, and you bring them in here, and you just say merge those properties into my messages, right? That's what traits mean. So going back to what we were saying earlier about how we define endpoints, right? Our AsyncAPI objects effectively and our info objects are essentially describing an endpoint, the metadata about it. Our channel object effectively, a little bit the information, some of the information there, the metadata about what's the name of the operation, etc. Effectively, what am I performing? To some extent, our metadata about the endpoint But there's also information really about the channel, right? But that's a bit of a mix between server and the channels object. The server is effectively the location that you need to go to talk to the channel, and the channel is effectively the name of the particular topic, or the routing key, whatever your broker of choice gives you. And the binding information is spread across servers, channels, and operation objects. But we fulfill the kind of criteria that we established earlier, right? AsyncAPI 3, I mentioned that earlier. So the nice thing on AsyncAPI 3 is they're addressing a few of these non sequiturs. AsyncAPI 2 is really, I would think it's probably early adopters, or late adopters rather, whereas AsyncAPI 3 I would hope would be the one to go for early majority. And you can see under operations, what we now have is we say, this operation idea refers to an action, which in our case is receive, right? But there's another one called send. So I'm actually saying, what do I do? Not basically, what do I expose? And then a description, etc., and the binding. And channels with their messages get lifted out. So I can define a channel, like, for example, restaurant onboarded, with its message, what does the restaurant onboarded message look like? And then I can define, for a given app, am I a sender or a receiver to that channel? And that lets us lift channel definitions with their messages out into a separate file, which means we can say, okay, when I'm documenting what I've got, I want to document that I've got channels that live on a broker, right? And I have apps that essentially either send or receive on that channel. So 3 is a little bit better at thinking about how we actually structure pub/sub applications generally. Okay. So if I'm going to use AsyncAPI, there's a nice thing called, it's slightly sliced off at the top, AsyncAPI Studio. AsyncAPI Studio lets me write my YAML. It's also available in JSON. JSON and YAML are the same thing, right? On the left-hand side. And then effectively I see on the right-hand side a generated HTML definition, which provides, if you like, out of the box, here's some documentation that's viewable by human beings who don't want to read YAML. Okay. We also, because nowadays that's, part of the course, have basically a plugin for visual code, which lets you essentially do exactly the same thing. So basically, it will recognize AsyncAPI YAML, and it will generate a preview of the HTML that you would generate if you used that. Awesome. It has increasing support across a range of enterprise-friendly tools. Who knows what Backstage is? Few of you. Backstage comes out of Spotify. It's basically their internal tool for documenting things that developers want to share with each other, including documentation of endpoints, etc., and APIs. It'll also do some code generation and stuff for you. So it supports AsyncAPI effectively alongside OpenAPI and GraphQL and gRPC and everything else they support. But AsyncAPI is a kind of first-class citizen now in Backstage. So that's, if you have a whole load of these and you want to basically host them somewhere, that's one way of doing it. There are a whole range of tools appearing which begin to support AsyncAPI. So I'm going to pick a couple of them because I want to give you an impression of an ecosystem that's emerging around it and why AsyncAPI is worth buying into over just this thing that's basically no one knows about apart from Ian. So this effectively is called Cupid. Cupid has an interesting thing. Cupid says, well, given you have effectively got apps that send and receive, I can build a graph of those. So I can graph out the nodes which show you effectively what's talking to what inside your enterprise, right? Just use a React to do that. The slight limitation today, and it's feedback that the AsyncAPI community has, but I'm not sure it'll be addressed in 3, is that we don't really know if your app receives foo and produces bar and baz, whether there's a connection between foo and either bar or baz. In other words, if we flow through thinking of basically some kind of workflow, when I get foo, I do some action and I basically raise bar. Or when I flow through, I take some kind of action, and in a good case, I raise bar, but in an error, I raise baz. There's no way of understanding whether the messages that you raise are in any way connected to the message you receive. There's no tracing, right? And that's an obstacle for all of us in the event space, but not that anyone else has solved it yet, but it's still a need. Okay, talk a bit about how tracing helps later. This is the event catalog. This is the kind everyone's a bit excited about at the minute. It's another open source project. AsyncAPI. It's someone said we need to build catalogs for our events. We better visualize them. We better document our APIs. It was, I think, an independent of AsyncAPI project, but it supports AsyncAPI, and I think the AsyncAPI community is very excited about it. And it's a really nice tool for effectively adding your APIs in, visualizing basically how they talk to each other. One we're looking at quite aggressively. It's early days for it, but we've been engaging with the maintainer, who's very proactive and giving some feedback on stuff that we need in it. But it's looking very nice, and you get these nice visualizations, which certainly helps. Okay. Describing contracts. So there are emerging standards for this section of the contract within AsyncAPI. I said AsyncAPI, the box, default is JSON schema. There are some emerging standards. One of the most interesting ones is CloudEvents. CloudEvents documents metadata, not payloads, metadata, right? And it comes mainly out of vendors wanting to basically agree a common standard for metadata for events. So if you are in, say, Azure and you're listening to platform events, they have basically a payload, but they have a set of headers, right? And the idea is across basically various platforms, they wanted to agree what the header structures would look like for events that they're raising, so that tooling effectively could listen to, etc. Apart from AWS, who doesn't want to be involved because they're the market leader and, you know, open standards. But CloudEvents effectively say, what should a header look like? Right. CloudEvents are interested in events and not commands. What is the difference? Okay. So events are facts and commands are instructions. An event is, I am thirsty. I could really do with a cup of tea. Or just I am thirsty would be an event, right? A command is, please make me a cup of tea. Right? That's the difference. Generally, with a command, we probably expect a reply. Right? There are fire and forget commands, but generally we tend to expect a reply. So a fire and forget command would be, please make me a cup of tea, and effectively I know what will happen. But generally I'm expecting a cup of tea, or someone saying, yeah, okay, I'll get you a cup of tea in. Right? Events are one way, nearly all the time. They just say something happened, I don't expect a response. Right? Later on, I might receive a signal that relates to some workflow, but I don't expect a response with an event. Events don't know their subscribers for that reason. Events are raised into the ether in case anyone cares about them, but I don't really know who they are. Commands always tend to have a known receiver, right? I know who the person that makes tea is, and I'm going to address them as opposed to anybody else, because that's how I get my cup of tea. And events have 0 to many subscribers, right? You may have no subscribers. You may be raising events and no one cares. Commands tend to have one subscriber, the person I'm talking to who's going to carry out this operation that I'm asking for, right? So typically when you have workflows where effectively you know there's another step which someone has to do, often before you can complete your step, you send them a command. If it's like, I've got some work and when I'm done with it, I'm done and I don't really care what happens next, that's an event. So CloudEvents really only supports the information on the right-hand side. So it's not going to give you information like what's the reply to header and things like that, right? It doesn't want to do that. It just wants to say, I care about events, because a lot of its case is optimizing for platform events coming from cloud providers. Yeah, okay. So when we are talking about CloudEvents, we say event consists of metadata and a payload. The metadata, which is what we care about, doesn't tell us anything about the payload, has required and optional attributes in CloudEvents. So the required events are an ID, a source, who's sending the message, a spec version, which version of CloudEvents am I going to, does my basically attributes come from, and a type, which is the name plus version. So greeting v1, greeting v2, it basically says, what is my message and which version of the message is it, all in one. It has a data content type. It says, when you look at the payload, what is it? Is it plain text? Is it binary, right? And a schema. And it says, if you want to know what the payload looks like, you should go here, and that's where the payload is defined, but it says nothing about how that payload is defined. It just says, there's a definition over here, and you can put that in, right? And there are optional attributes, those two, data content type and schema. You don't have to have those for CloudEvents. All right. Subject, which qualifies the source, that says, what is this about, right? And a time, when did I send it, right? Pretty obvious, okay. As we say, nothing about data. So cloud events can be basically binary or structured. If you thought publish and subscribe was a bit confusing, this is even worse, right? So cloud events basically, binary and structured is nothing to do with whether you are sending information in binary or kind of plain text format. What they mean by that is binary says, oh, the protocol I'm using has some idea of metadata, of headers for messages, just use that. Structured says, ignore all that, whether it has it or not, put it all in the body and have the body have an envelope and a body, right? It supports a whole set of protocols. More have probably appeared since I put this slide together, and they tend to be quite responsive about adding new ones. Okay. Binary looks a bit like that. So this is Kafka. I can't remember which version Kafka started to support headers in, but effectively you can see all the CE underscore properties. They are cloud events properties saying effectively, hey, here effectively is my version, my type, my source, my ID, and my time, right, etc. Okay. And then this would be the same thing in structured. Still over Kafka, right? But it's saying effectively, actually, the first thing I need to do is define this body, and this is plain text, and the body's going to effectively say, okay, here are all my headers, then here is my actual application data. All right. It is up to you which you prefer. Gosh, we've had a lot of fights about this internally at my place. I think my personal preference is use binary where it's available, because the broker has made available the option for you to basically separate out the metadata information, and it may be possible for you to use that in the broker to do operations without inspecting the body. So for example, with SNS, I can create a filter that effectively just looks in the header and says, I'm going to route things over here, or I'm not going to give you these messages, etc. So I would tend to use the support for effectively explicit metadata if you can, and only use basically putting it in the body if you have to. All right. Given that I have schemas, I might want to store them somewhere. Although I am pointing at Confluence Schema Registry, it is just to give you an example of what they do in a picture. I'm not advocating you use this over others. So generally, a schema registry effectively says, I am just a huge big dictionary where you can store your schemas, and generally your producer will register one and your consumer will consume one. Something like Confluence Schema Registry actually lets you check at runtime whether messages that are being sent or received conform to the schema. I'm a little bit, I don't know whether that's necessarily a great idea. I would tend to want to do that at design time and not have you release something that basically would break somebody else. But you can also use it for that. And they also provide the ability to do some kind of forwards and backwards compatibility. All right. So generally, one of the big problems in messaging is versioning. In other words, I change my contract and I don't think about everybody that's involved, and essentially I break people. Tools like the Confluence Schema Registry tend to give you schema versioning. In other words, what they will do for you is they will tell you when you upload a new schema whether it is forwards or backwards compatible with older versions of the message. That's a useful health indicator to you to say, I might have broken somebody, right? It's quite possible that you've chosen to drop a field that nobody is using, in which case you haven't broken anybody, but you have to negotiate at that point to determine whether you've actually broken somebody. It's one reason why I'm not a huge fan of runtime checks, is because actually I might not have broken anybody. It is if you like a slightly less full-fledged version of consumer-driven contracts. Consumer-driven contracts effectively say the consumer registers exactly what they use, and the producer effectively validates that effectively their schema matches all of those consumer contracts. What we're doing here is just saying, when I look at this version of your schema and I look at the last version of the schema, what can I tell you about the compatibility of it, right? If someone was to consume that message beforehand and consume all the fields on it with all those relevant types, would they break? based on this new message. Effectively, and it'll ignore things like I'm adding fields, etc. Effectively knows that you can tolerate those. But what it will do effectively is say, you would break. Whereas CDC would say, I will look at exactly what's being consumed. You can drop a field if no one's consuming it, right? But CDC tooling is, there's not really anyone who's producing anything that useful. Pact exists basically for HTTP. It also has some support for messaging. It doesn't, to my mind, work particularly well because you're faking out brokers by using mocks in the middle, and it's overcomplicated, I think, for what it needs to be, which is really, hey, I can effectively demonstrate by looking, a simple set operation, whether or not effectively you should support that. But there's poor support for CDC at the minute. The best thing out there at the minute probably is schema registries. This is free, open source, right? So you can go and grab Confluence schema registry. It is it is not tied to Kafka. You can use it for other basically systems. It supports basically Avro, plain text, and protobuf for the schema definition of the protocol. Observability. All right. So we mentioned effectively that one of the problems, particularly in messaging, was tracing. Understanding basically the flow. We also obviously want to have some observability of our messages in production so we can manage them properly. So one of the things that I would probably want to do here is essentially say, use something like OpenTelemetry. What happens with OpenTelemetry is this operation, I'm onboarding a restaurant, and when I onboard a restaurant, messages flow throughout my system and set up the things that need restaurants would be what we call a span. And within that span, effectively, there are child spans that essentially say, I am now inside restaurant availability, which is doing whatever it does with me, right? And what happens is you can serialize the span information for OpenTelemetry into your headers so that effectively you pass it along as kind of a kind of context to everybody who down the line. Typically, a span effectively has an operation name, a start and finish timestamp, a context, and various attributes that you define, right? Okay. With infrastructure as code, it's probably the interesting bit at the end. So how are we using things like AsyncAPI? So one of the interesting things with AsyncAPI you can do once you've defined it all and you published it is you can parse it. And the AsyncAPI and its GitHub repo provides a parser which will basically parse the JSON or YAML for you essentially and turn it into an object model. And then effectively, you can use the object model out of the box as the generator that works either React or Nunjuk templates, but you could use other things because the generator and the parser are separate projects. Once you parse something, the generator lets you say, I'm going to use React to create a template, and I'm going to turn what I've parsed into something else. I'm going to produce a new document, right? So this file produces one or more new files, right? So here's an example of the React template doing that. Essentially, we say, hey, I've got basically some AsyncAPI. What I'm going to do here, a bit hard to read, so I'm going to basically say, look at that, basically determine whether I have any channels, so it has published that I'm subscribing. So do I have a Kafka subscription on any of my channels? If so, what I'm going to do is create a new file called Kafka YAML, and effectively I'm going to basically spit out some configuration information based on reading the bindings for that particular endpoint, right? Don't write the detail, but just understand the principle. Okay, so what we do with that then is, the simple thing you could do is generate some HTML documentation, but what we do that is effectively provision infrastructure. So we take some Pulumi, basically feed that YAML into Pulumi and say to Pulumi, please go away and generate the relevant infrastructure for us. Go and create the Kafka topics, go and basically do all the security that we need. Effectively, I'm going to provision stuff. What that saves us from is, something goes wrong in production, somebody cleaning up thinks these topics aren't needed anymore, deletes half of them. Turns out basically you needed one. Not that's ever happened. And effectively you want to recreate them, and rather than having to redeploy all the apps because the apps basically create their own infrastructure, you effectively have declarative state, so you can essentially say, hey to Pulumi, please recreate everything for me because somebody broke it. Okay. There are lots of other ideas probably that work from this model, but that's one that basically we started to use. And I think it's a really interesting capability that comes out of putting stuff into AsyncAPIs, the ability to then turn that into basically something that's parsed and then generate new artifacts from it. Typically what we do is we just generate, because we take the original YAML, generate some new YAML, because you can't have enough YAML, right? And then our code effectively reads that YAML and does stuff with it. It just makes just simpler than getting anything to understand AsyncAPI. We just get to understand the 6 or 7 things we need in order to provision the infrastructure. All right. And you can do scaffolding, so you could use the same thing to do code generation. So effectively, if you always tend to write the way a worker that consumes messages from Kafka in the same way, teams can basically just say, you know what, I'm going to define my endpoint in AsyncAPI, press a button effectively, and I'll get the first version generated, and I just go and write basically the relevant code, right? Which saves all that grunt work of doing all that configuration and getting it right. You know, if you just got a template that you want to use. All right. And that's, it ends a bit abruptly. I can't think of a way of letting you all down gently, but there you go. All right. And that's that. Thanks very much.